The image classification is performed on different image data with predefined labels. So this is called label data. Machine learning is divided into mainly three types. They are supervised learning, unsupervised learning, and reinforcement learning. So what is supervised learning? It is a process how the machine identify a particular image with the help of the data set in the system. Dear students, welcome to Computer Science classes. I am Ravi Kumar KR, lecturer in Computer Science, Vidhyaashram First Grade College, Temple of Excellence, MYSURU. Students, let us start our discussion with the chapter Learning or Machine Learning, that is in Unit 4. In this session, we are going to talk about the introduction to machine learning and forms of learning. These are the topics to be covered in this session. Let us start with the definition of what is learning, or in other words, we can say what is machine learning. So the definition goes like this. This machine learning is a part of AI system which enables the machine to automatically learn from the data, improve the performance from the past experience, and make predictions. See, this is the main concept of AI or artificial intelligence. So machine learning is a part of artificial intelligence. What is the purpose of this machine learning? So here the machine, it is a machine itself learn from the data or from the experience and improve their performance from the past experience and make predictions. So that is why we are using artificial intelligence. So we are making a computer to think like human beings. So that is the meaning of machine learning. So how human beings we can take decisions. Now this machine learning contains a set of algorithms that work on a huge amount of data. Of course, in a machine, in artificial intelligence, so it deals with or it works with a set of algorithms. And we have seen in our previous sessions and different types of algorithms. And those algorithms work with large amount of data. Data is fed to these algorithms to train them, and on the basis of training, they build the model and perform a specific task. So this is the functioning of machine or artificial intelligence. So what is the meaning of this here? So here we know algorithms. All AI systems are with or works with different types of algorithm based on the input as well as circumstances. And we are going to train them with the algorithms, and data is fed to these algorithms. And with the data is going to algorithm, and with the help of algorithm we are going to train the machine or train the computer, and they will build their own model, perform a specific task. So the main concept here is the data is perceived from the system, or data is we fed into the computer system or AI system, where it goes to algorithm. Through algorithms, it will be trained through algorithm, and themselves they build their own model depending on the input as well as the algorithm, and perform a specific task. Or so here one application. So if we have one algorithm, it does only for one work, or one algorithm is designed only for one particular type of work. This is the basic definition of machine learning. In the next slide, we will see what are different forms of learning. And here, based on the methods and way of learning, machine learning is divided into mainly three types. They are supervised learning, unsupervised learning, and reinforcement learning. These are the different methods of learning or forms of learning. Let us see what is the definition of supervised machine learning. Supervised machine learning. Now, if you look at the definition here, it is a learning technique. It is one of the technique. We train the machines by using labeled data set, and based on training, the machine predicts the output. So please know that here this supervised learning work with the labeled data. So the meaning of, we are going to learn the meaning of labeled data in our next slide. So here the labeled data is specified. Some of the inputs are already mapped to the output. Though what is the meaning of this here is some of the inputs are already mapped to the output. For example, so in this example, this is the data set. Here, for this is the input, for example, so output is B. And for this is the input and output is D. See, this is the meaning of the sentence here. The labeled data specifies some of the inputs are already mapped to the output here. So this is the meaning of data set. So here the supervised machine learning is a technique where it works with the labeled data. This is the meaning of labeled data in a data set. Here, what is the meaning of this? We are having here number of different combinations and for different input and for which the different outputs. All these are stored in a data set. So supervised machine learning works with the labeled data. That is the meaning of the word labeled data. And here first we train the machine with input and corresponding output, and then we ask the machine to predict the output using the test data set. See, this is the functioning of supervised machine learning. We'll train the machine like for this is the input, this is the output. So we are training with the data set here. So then we are asking the machine, so we will ask the machine to predict the output for another type of input. So what is the output for this type of input? See, this is the based on the data set. Data set already here, inputs are mapped with the output. So this supervised machine learning works with the data set. They are referred as labeled data. In the next slide, we will see, for example, input data set of cats and dog images. Imagine that for an example, we have a data set. In the data set, we have a cats and dogs images are there in the data set. First, we will provide the training to the machine to understand the images such as shape, size of the tail, everything, and dog. Shape of the eyes, color, height, and so on. So that is what is the meaning of data set here. So as we seen in the previous slide, suppose we have a data set here. So here we are in this example, we are going to have the images of, for example, cats. Image cat. So here we train with all the features of cats. So for example, in terms of shape, size, tail, and also eyes, color, everything. So this is a data set. In the data set, we have given the features of cats. Similarly, we also give in the data set, we also give the features of dog. So here we are giving all the details. So next one is, so based on this data or the features available in the data set, we are going to ask the computer, suppose if I give another image. For example, if I give the image as with one image. So here, so whatever the image we input to the data set or to the computer machine, so is going to map the input with the corresponding output. Then is going to display whether this image belongs to cat or belongs to dog. See, this is the meaning of supervised learning or the definition of supervised machine learning. So here the machine is well trained, so it will check all the features of the object. For example, here object is cat and dogs. So we have given the features of the object such as height, shape, everything, and find that it is a cat. Suppose if the image is cat, if you give the input image as a cat, it gives the output as cat, where the input is going to match with different features of cats. Suppose if your image is, if you given the input image as a dog, it's going to give the output as dog. So based on that is the learning technique. So this is supervised machine learning. In the next slide, so it will put in the cat category. This process is how the machine identifies the object in supervised learning. So what is supervised learning? It is a process how the machine identify a particular image with the help of the data set in the system. The main goal of supervised learning is to map the input variable x, to map the input variable x with the output variable y. So, as you have seen in the previous slide, so here if we have to map the input variable y, we have to map with the output variable b in this example. So, that is this point. Now, some real world applications of supervised learning are risk management, fraud detection, and spam filtering are example for supervised machine learning. In the next slide, we will see now what are the category of supervised learning or what is the classification of supervised learning. Here there are two classification. One is itself is called classification, or we can say methods of supervised learning. So one is classification. So what is classification? It is the process of finding a function which helps in dividing the data set into classes based on different parameter. So this is classification under supervised machine learning. Here is finding the function which helps in dividing the data set into classes based on different parameter. So the meaning here is if we have so many data sets, we are going to categorize it. We are going to separate them based on some characters or some features. That is the meaning of classification. In classification, a computer program is trained on the training data set, and based on the training, it categorizes the data into different classes. So here, what is classification? The concept here is the data set in the system is divided into, or we separated them into different classes based on certain criteria. That is classification. The task of classification algorithm is to find the mapping function to map the input x to the discrete output y. This is mapping the input to output variable. For example, in email spam detection, this is one of the example here. The model is trained on the basis of millions of emails on different parameters. And whenever it receives a new email, it identifies whether the email is spam or not. See, this is the meaning of classification. So what is the meaning of classification here? If you look at the example here, if you have email system, and here we have different, if you look into that, we have different boxes like categories inbox or maybe outbox or sent box, and again maybe a spam. One example is spam folder or a category, small category. So what is the meaning of this? Whenever you get the mail from anyone else, for some other user X, and it goes to particular folder automatically. Here the user, we will not put into different folders manually. So it goes to the different folders automatically. That is based on the supervised learning. That is the definition of or example for classification. Here, how the spam mail. If at all any spam mail in your email box, it directly goes to spam folder. That is based on classification. So here, the classification is nothing but process of the here email is your data set. You can take it as email is a data set. We are categorized into, or we are classifying into, divided into number of subcategory based on the features. How, in the simple example, how spam mail goes to spam, or any all mails coming into inbox, and any mails you have sent, it goes to outbox. All these are examples for classification under supervised machine learning. In the next slide, regression. So this is another method of supervised learning. One method is classification and second one is regression. So what is the definition of regression here? Here the output variable must be of continuous nature or real value. Here please understand now, there is no classification here, there is no bifurcation of data set. Here we are getting a continuous value or real value, that is example for regression. The task of regression algorithm is to map the input value x with the continuous output value y. See, there is no classification, there is no classes. So this algorithm are used with continuous data, and we try to find the best to fit the line which can predict the output more accurately. And it can be used to solve the regression problems such as weather prediction, house price detection, and market trends. See, in regression, we don't have a classification here. Very good example is we are going to look for the real value of this. For example, weather prediction and house price prediction. If we talk about the real estate, how the house prices are varying, how we are going to monitor it, and how we are going to access or predict the value. And again, marketing trends in the field of business, the trends in the market, all these are example for regression. And here data set is not going to bifurcate into number of subclasses or classes, that is classification. Regression is only looking for a continuous nature of value or real world value. These are the example for regression. Next, let us see what are the advantages of supervised machine learning. It works with the labeled data. So we have to keep in your mind, supervised learning is work with the labeled data, and you can have exact idea about the classes of the object. So as we have seen in the example of cat and dog, isn't it? How the input what we give it based on that it goes to different category. So here it is possible to have the exact idea about the classes of the object. So this object belongs to which class? That is easy for us to identify in supervised machine learning. And it helpful in predicting the output on the basis of prior experience. That is the advantage of this. Now what is the drawback of this? Disadvantages: not able to solve complex tasks, and it may predict the wrong output if the data set is different from the training data. The main drawback is that it cannot work with the complex data set. Now it requires a lot of computational time to train the algorithm. So it requires more time for training the algorithm. Disadvantages of supervised machine learning. Now let us see what are the applications of this. One is image segmentation. Means the image classification is performed on different image data with predefined labels. So this is called labeled data. And medical diagnosis means it are also used in medical field for diagnosis purpose. And it is done by using medical images and past labeled data with labels for disease and conditions. So this is the meaning of labeled data. Here we have a label for a particular disease, and we have a label for some other past experience models, and we have some other name for different images. See, this is the meaning of labeled data. With such a process, the machine can identify a disease for the new patients. This is based on the supervised learning method. Another application is fraud detection and identifying fraud transaction, fraud customers, etc. It is done by using historic data to identify the patterns that can lead to possible fraud. So here the pattern in the sense the features, how we can see in the example of dog and cat images, that is image processing. Similar to that, the features of those two animals, similarly those are nothing but patterns. So it is going to learn with the patterns. Next one is spam detection. Spam, as we have seen in the example. So any spam mail which are entering to your mailbox, it goes to respective spam folder. Now speech recognition, and it is algorithm are used to in speech recognition process, and it is trained with the voice data, and various identifications can be done using the same, such as voice activated password, voice commands, etc. So these are all different applications of supervised machine learning. In the next slide, we will see unsupervised learning means another forms of learning. One is supervised learning, second one is unsupervised learning. So what is the definition of all these things? So it is works with unlabeled data. So it is, if you talk about supervised data, supervised learning, it works with the labeled data, and it is unlabeled data. And here it is uncategorized data, as we have seen in the example of forms of supervised machine learning. We have classification and regression. This is, there is no concept of bifurcation and no concept of separating. So uncategorized data and no knowledge about the input and output of the problem. See, this is what the another difference between those two. As we have seen in the supervised machine learning, here in the data set we have information about, for this particular input we are mapping with the output variable, but here there is no prior knowledge about input and also the output of the problem. That is the main difference between these two. Now output depends on algorithms or nothing but model which we are going to create, or it is going to create by itself with the help of experience or by the past data. Now computer teaches the user, unlike supervised learning based on the pattern. So here in the supervised learning we are training the algorithm, or the machine learn from the algorithm trained by the data set from the user. But in unsupervised learning, so here the machine is learning, or it make the user to learn from the model. That is the difference between these two. And here no trained data. And example is search engine. If you look at search engine, it results in number of web pages or more number of results. So there is no one particular output for one problem here. Suppose if you are looking for one information in a website, and if you type the particular word, and it is going to map with number of words in different websites. So accordingly, it's going to display n number of websites for particular word or a particular phrase. So based on that, so this is also an example for unsupervised learning. So here there is no exact one data is going to display number of results, and here the user has to select the best result among many results displayed through the system, and it can classify, label and group the data points contained within a data set without requiring any external guidance to perform the task. And here, if you observe this in supervised learning, in the data set, input is mapped with the output variable. And here, we are going to train this data or train the algorithm through the features we are giving input to the system. But here, it is opposite to that. Here is within the data set, without any external guidance, is going to classify the data. In other words, unsupervised learning enables a system to identify pattern within the data sets on its own. It's going to develop its own model to solve a particular problem. So here, AI system groups unsorted information according to similarities and differences, even though no categories are provided. As we have seen in the supervised learning, in classification, we are going to have a labeled data. We are going to have a label for particular data set. But here, without providing any data set or any label, by itself is going to create a model, and is going to separate the data set from the algorithm. Next, let us see what are types of unsupervised learning. We have something called clustering here. So what is the clustering here? It is going to categorize the result based on some methods. And here are some models. One is customer segmentation. So this is one type of clustering, but there we have classification in supervised learning, and here in unsupervised learning, we have clustering. So, grouping of customers with similar buying habits or demographics. And here it is possible to have, suppose you have a provision store and we can make out the n number of or different category of people are walking in and they are going to purchase the provisions or the item of their requirement. And here we can categorize the customers into different category by having with different habits. Next we move on to image clustering. So organizing images based on visual similarities. This is another application. Document clustering. It is grouping documents by topic or content. So we can separate the content based on the headings or the document. These are the clustering. And hierarchical clustering. See, these are all different types of clustering under unsupervised learning. Next rule is association rule mining. See, this is one of the type of unsupervised learning. So what is the meaning here? Is a data mining technique. Association rule mining is a data mining technique used to uncover interesting relationship between the items in a data set. Now, it doesn't rely on predefined labels or categories. So this is generally unsupervised learning. It works with the unlabeled data. And the goal is to identify strong rules that describe how frequently certain items are found in categories. And here, the rules often expressed in if-then format. For example, if a customer buys X, then they're also like to buy Y. See, observe this. So, if you look at the example now, you can understand the meaning of the characters what we have listed here. You take an example like Amazon. See, whenever you're looking for particular images or items in Amazon, so immediately below you'll get one option, the people also purchased the following items. Or you can also get a message or images where you get a message like the peoples also brought this along with this item. And also you may get a message. Suppose if you buy something like a mouse in a computer, so you'll get immediately a message or image saying that, so one who brought mouse also brought keyboard or maybe computer accessories. See, these are all nothing but the association rule mining. So that is the meaning of if a customer buys X, then it also like to buy Y. I mean, it's going to give the output or in display something which are related to the input is going to display the output. So this is the concept of association rule mining. So in the next slide, reinforcement learning. So another category or another forms of learning is reinforcement learning. So it is a machine learning approach where agent learns to make decisions in an environment to maximize a cumulative reward. Okay. Now it is based on the principle of trial and error, where the agent learns by interacting with the environment and receiving the feedback based on its action. Next one is the goal is for the agent to discover the optimal policy. So this is the main aim of this, which a set of the rules for making a decisions in a different situations to achieve the highest possible rewards. For example, very good example for this is chessboard. You take a chessboard. Here, every movement is instantaneous and cannot guess the next movement here. So what is the meaning of this? Here, the output of this cannot be decided. It depends on the environment. So based on the environment, so this model going to take a decision based on this. For example, very good example is a chessboard. Whenever you are going to play chessboard with the opponent and you cannot guess the movement of the opponent who is playing with you. So that is an example for reinforcement. Here we cannot guess the next movement at all or the proper or right output for the particular environment, a particular problem. That is reinforcement learning. In the next slide, we will see one more example. If there is an option like water and a fire, so there are two options will be given to a user. One is water and a fire. And the agent has to select the best of it. See, this is the meaning of reinforcement. Here, there are two options for him. One is water and a fire. So, whichever the one is going to prefer or the agent is going to select it, there is an example for reinforcement learning. Here, the agent learns to make decisions in the environment. See, in the example I told you about, water is an environment, fire is an environment. In the previous example, chessboard is an environment. So, learn from the environment to maximize cumulative reward signals. So, this is cumulative reward signal. So, it is like teaching a robot to play a game where the robot explores different actions, receives feedback, rewards or penalties, and learns to choose the best actions to achieve the goal. A very good example is we are learning with a robot. Very good example. Also, you can say that whenever you're going to play a chessboard with the computer system, that's also an example for reinforcement learning. So, immediately, suppose if you are playing with the computer system, any movement you made it, immediately is going to respond with the different move. That is an example for this type of learning system. It also learns from the rewards and penalties. Rewards and penalties. So, what is the meaning of this? For any of the right selection, you can keep on adding rewards. So, if the rewards are going to increase like anything, then that would be the best action, or that would be the best algorithm. Suppose also it depends on the penalties. If there is a more number of penalties for particular movement, particular action from the system, then it gives the negative feedback. So, then that may not be the optimal algorithm for a particular problem. So, that is the concept of rewards and penalties. And very good example even for this is in online shopping. Whenever you go for any of the website, either Flipkart or Amazon, we are going to buy a product by looking at the feedback from different customers. And also there are number of stars, maybe star 1, star 2, 3, 4, 5. So, that is nothing but the feedback. So, we are going to buy the product by looking at the feedback of that. Suppose if the feedback is 5 out of 5, we assume that that is a good product. So, we may go to buy for that. Suppose if we see that the reward is maybe around for 1 or 2 out of 5, we assume that that may not be the particular product, may not be so good. So, we are going to drop that. We look for some other product. So, same concept here is penalties and rewards also in the form of feedback. Here in many business or any marketing analysis is based on the feedback of any person or the people or their customers. So, this is a type of a learning where it's going to work with this concept, that is reinforcement learning. Students, so far we have learned the basic definition of learning or machine learning and different forms of learning. Let us continue our discussion in my next session. Thank you so much.